This video is on limits, and specifically the limits of sequences and series. Let's review these three different vocab words here. A sequence. A sequence is a list of numbers. So for example, 5, 10, 20, 40, 80, etc. is a sequence. A series is very similar, except it is the sum of those numbers. So a series could be 5 plus 10 plus 20 plus 40, etc. How about the word limit? The word limit is a noun and it means the furthest boundary. Here it is translated in Chinese, Spanish, and Vietnamese. So when we're talking about the limit of a sequence f of n has a limit if f of n gets close to a number as the sequence continues, or as the sequence keeps on going towards infinity. If that f of n gets close to a number, then it has a limit, and that limit is this number. Let's do an example. So here we have the sequence f of n. This sequence f of n is defined as the sequence 1/2, then 1/4, 1/8, 1/16, etc. In this sequence, as the numbers keep on going, as n goes towards infinity, my f of n keeps on getting smaller and smaller and smaller and gets close to 0. Another way of putting this, so as the sequence keeps on going, our f of n is getting closer and closer to 0, or as n goes towards infinity, f of n goes towards 0. Now we should note here that although f of n is getting close to 0, f of n actually never reaches 0. That's a minor technical point here. So, because as n goes towards infinity, f of n goes towards 0, another way of just saying this is the limit of the sequence f of n is 0. Let's put all this into decimals, because some people have an easier time seeing that this is true with decimals instead of fractions. So here's our f of n. The list we just had previously said 1/2, then 1/4, then 1/8, then 1/16. And here it is in decimals. 1/2 is the same as 0.5, 1/4 is the same as 0.25, etc. So as you notice, this number keeps on getting smaller, smaller, and smaller. And if we were to continue going down, as the sequence continues, as n goes towards infinity, this f of n number keeps on getting smaller and smaller and smaller, heading towards 0. So here was an example of a sequence that had a limit of 0, but not all sequences have limits. Here's an example of a sequence that does not have a limit. G of n here is defined as the sequence 2, then 4, then 8, then 16, etc. And for this particular example, as n goes towards infinity, our g of n just also goes towards infinity. Or as the numbers keep on going, g of n just keeps on getting bigger and bigger and bigger as well. And because g of n is not getting close to a number, g of n does not have a limit. So in general, when we're talking about arithmetic sequences and geometric sequences, how can we tell if it has a limit? The general rule of thumb, geometric sequences will have a limit if the r value is between -1 and 1. And our r value is how much did we have to multiply in order to get the next number. So here, our r value is 1/2, because to go from this one to this one is times 1/2, times 1/2, times 1/2, times 1/2 to get the next number. So this one had an r value of 1/2, and because that r value is 1/2 and that r is between -1 and 1, that geometric sequence, f of n, had a limit, which we said was 0. Now, if you have a geometric sequence where the r value is either bigger than 1 or smaller than -1, it will not have a limit. Our previous example of a sequence not having a limit, here our r value was 2, because it goes times 2, times 2, times 2. And geometric sequences with r values bigger or equal to 1, smaller or equal to -1, will not have a limit. Along those lines, arithmetic sequences never have a limit. All right. And quick reminder, with arithmetic sequences, to get the next number, you're either adding or subtracting. So if the sequence was +3, +3, +3, +3 to get the following number, that would be an arithmetic sequence. And arithmetic sequences just never have a limit. So that is about sequences. How about series? So next part of this video is talking about the limit of a series. And many of the things that are true about a sequence is also true about a series. The one big difference just being that a series will be the sum of those numbers, or the sum of a list of numbers, while a sequence is just that list of numbers. But most of the things in terms of how limits work with sequences or series, most of that is the same between a sequence and a series. So, a definition of a limit of a series, the series capital F of n will have a limit if that capital F of n is getting close to a number as n goes towards infinity. And once again, that number will be the limit. Let's use that same sequence before, and let's just use it as a series. So, capital F of n, we're going to define it as the series 1/2 plus 1/4 plus 1/8 plus 1/16, etc. And here, as n goes towards infinity, our sum, capital F of n, will go towards 1. Or as we keep on adding more and more numbers to this series, the sum is going to get closer and closer to the number 1. Just like in a sequence, this actually never reaches 1, but it does get closer and closer to it. So for this particular series, the limit of this series, f of n, is 1. This is usually easier for students to tell that this is happening when we do it with decimals. So let's change all this to decimals. So we're going to change 1/2 plus 1/4 plus 1/8, etc. So 1/2 is, this is the decimal for 1/2. If you have 1/2 plus 1/4, 1/2 plus 1/4 plus 1/8 plus 1/16, add the extra plus 1/32. And so as you notice, as we keep on going with the n's, as the n increases, my capital F of n, the sum, keeps on getting bigger and bigger, but specifically it's getting bigger and getting closer to 1. Okay, just like in a sequence, not all series have limits. And here's an example of a series that does not have a limit. A capital G of n, where I'm defining G of n as 2 plus 4 plus 8 plus 16, etc. Here, as n goes towards infinity, G of n just keeps on getting bigger. The sum just keeps on getting bigger and bigger and bigger, heading towards infinity. And once again, because G of n is not getting close to a number, capital G of n here does not have a limit. And when looking at limits of arithmetic series and geometric series, it does follow the same rule as for sequences. So if a geometric series has an r value between -1 and 1, it will have a limit. Along those same lines, if a geometric series has an r value that's either bigger than 1, bigger or equal to 1, or less than or equal to -1, it will not have a limit. And arithmetic series never have a limit.